Hello dear students, today we will discuss about a concept called matrix, and today's question is a matrix with dimension m by n is known as a dash matrix. Option A, row vector, option B, column vector, option C, symmetric matrix, and option D, identity matrix. So this question can be easily solved if we have enough knowledge regarding a matrix. Okay, so now here question arises, what is a matrix? Matrix is basically defined as a rectangular array of numbers in vertical columns and horizontal rows. Okay, so I am repeating, matrix is a rectangular array. Array means arrangement of numbers in vertical column and horizontal row. That means if we arrange numbers in columns and rows, then we can call it as a matrix. Now again here question arises, what is the need of a matrix structure or matrix algebra? So in economics we know we have to deal with n number of entities, whether it is an individual entity or it is farm or any kind of industries, any kind of variable, because in society we have n number of entities. That's why to deal with n number of entities, matrix is very much required. Yes, we have simultaneous equations to deal and handle that problem, but matrix algebra is quite simple to explain or to find out the problems relating to n number of variables. So that's why we have matrix algebra in economics. So as I have already told you that matrix is a rectangular array of numbers. So here we can see that this is an example of matrix. Here I have written A equals to 1 2 3 4 5 6 7 8 9. So these 1 2 3 4 5 6 7 8 9, these are called the entries or elements of matrix. I am repeating again. So these 1 2 3 4 5 6 7 8 9 numbers, these are called entries or elements of a matrix. Okay, and here we can see that we have 3 number of rows and 3 number of columns. Okay, we have 3 number of rows and 3 numbers of columns. So this matrix is a 3 by 3 matrix. Here I want to tell you all another concept of matrix called order of a matrix. Okay, so generally we write order of a matrix as m by n. Here m equals to row and n equals to column. Okay, so here you all can see that this is a 3 by 3 matrix. That means the first number in the order is called the row and the second number in the order is called the column. That means m is here the row and n equals to the column. Okay, so I think you all are getting cleared. So this is about the definition of matrix and an example of matrix. So let's come to the types of matrix. Okay, so coming to the types of matrix, the first type of matrix is a square matrix. Okay, this is a square matrix. So what is a square matrix? If we have equal number of rows and columns in a matrix, then we can call that a square matrix. I am repeating, if we have equal number of rows and columns. So I have already told you that if m by n is the order of the matrix, and here m equals to row and n equals to column, and if in a matrix we find m equals to n, if in a matrix, we find m equals to n, that means row equals to column, then we can easily call it as a square matrix. So here this is an example of square matrix, that is A equals to 1 2 3 4. We have 2 rows and 2 columns. So here m equals to 2 and n equals to 2, that means m equals to n equals to 2. So this is called a square matrix, or we can say that A is a square matrix of order 2 by 2. Then second type of matrix is rectangular matrix. Okay, so in case of rectangular matrix, the number of rows are not equals to the number of columns. So the number of rows, that means m, is not equals to n here. In case of rectangular matrix, the number of rows are not equals to the number of columns. So you all can see here the example, that is A equals to 1 2 3 4 5 6. That means we have 2 number of rows and 3 number of columns. Okay, this is a horizontal arrangement and these are the vertical arrangements. That means we have 2 rows and 3 columns. Here m equals to 2 and n equals to, that means column equals to 3. Okay, so since rows are not equals to the number of columns, so this is called a rectangular matrix. So first matrix was the square matrix and second matrix is the rectangular matrix. Then come to third type of matrix, that is we can say row matrix or row vector. Okay, this is an important form of matrix. So row matrix and row vector. So what is a row vector or row matrix? A matrix consisting of only one row and any number of columns. That means if in a matrix we are finding only one row and any number of columns, then we can call that as a row matrix or row vector. So here you all can see that A is a matrix which contains 2 elements, that is 1 and 2. So here we can find only one row and 2 columns. Okay, I am repeating, here I am finding only one row and 2 columns. So here m equals to 1, that means m equals to or row equals to 1 and n equals to 2, column equals to 2. So since we have only one row and two number of columns, so we can call it a row vector or row matrix. And the another type of matrix is column matrix and column vector. We can say that this is the opposite of the row matrix or row vector. And what is a column matrix or column vector? A matrix consisting of only one column and any number of rows. So if in a matrix we are finding only one row and any number of column, so if in any kind of matrix we are finding only one column and any number of row, that means we can call it as a column matrix or column vector. So here in this example we all can say that A and the entries are 1 and 2. So we have only one column and 2 rows. Okay, so here m, that means row equals to 2 and column, that is n equals to 1. Okay, so we have only one column and 2 number of rows. So this is called a column vector. This is also important. Then another type of matrix is called a zero matrix. Okay, another type of matrix is called a zero matrix. Then what is a zero matrix? If all the elements of a matrix are 0, if all the elements or entries of a matrix are 0, then we can call it as a zero matrix. Here you all can see the example that A equals to 0 0 0 0. That means all the elements of A matrix are 0. So we have here two rows and 2 columns and all the elements are 0. So this is a 2 by 2 zero matrix. Zero matrix. Okay, this is a 2 by 2 zero matrix because we have 2 number of rows and 2 number of columns here. Then another type of matrix is called identity matrix. Okay, then what is an identity matrix? So if all the diagonal elements, you all have to remember this concept called diagonal elements. If all the diagonal or principal diagonal elements, you can write it as principal diagonal elements. Okay, so if all the diagonal elements or principal diagonal elements of matrix are one or unity, then we can call it as an identity matrix. Okay, so here I have given an example like A equals to 1 0 0 1. This is a 2 by 2 identity matrix. So you all can see that this is the principal diagonal element. Okay, and this is the principal diagonal element. That means these are 1 1 1. That means unit or 1. So that's why this is called an identity matrix. So I think it will be better we take a 3 by 3 matrix. So let's take a 3 by 3 matrix, that is 1 0 0 0 1 0 0 0 1. So this will be very much clear, like we have 3 by 3 matrix. So you all can see that this is called a principal diagonal. Okay, this is called the principal diagonal, and these are called the off diagonal elements. 0 0 0 and this 0 0 0, these are called off diagonal elements. 1 1 1 are called principal diagonal elements. Okay, so here we all can see that the principal diagonal elements are 1. So this type of matrix are called identity matrix. Okay, then come to another type of matrix, that is called scalar matrix. Okay, so and here I also can tell that identity matrix is always a square matrix. Identity matrix, you all can note it down, that identity matrix is always a square matrix. That means the number of rows in the matrix must be equals to the number of columns. Okay, the number of rows in the matrix must be the number of columns. So next come to scalar matrix. Scalar matrix is also a type of square matrix. Square matrix. Okay, because here always the number of rows equals to the number of columns. In what is scalar matrix? If all the diagonal elements, principal diagonal elements, if all the principal diagonal elements of a matrix are same and identical, are same, you must have remembered this, the same and identical. If we found all the principal diagonal elements are same in a matrix, then we can call it as a scalar matrix. So here you all can see that A is a matrix which has the elements like 2 0 0 2, and these are the principal diagonal elements, these are 2. Okay, so here this element equals to this element, so this is called a scalar matrix. If we take a 3 by 3 matrix, like B equals to 2 0 0 0 2 0 0 0 2. So here this is a 3 by 3 matrix, and you all can see that these are the principal diagonal elements and these are all equal, that means 2. Okay, so this is a kind of this can be 3 4 5 6 any number, but all the elements must be identical in nature. So this type of matrix is called scalar matrix. And coming to next type of matrix, this is a diagonal matrix. Okay, so what is a diagonal matrix? So if all the elements except the principal diagonal, I am repeating, if all the elements except the principal diagonal are 0, called diagonal matrix. So this is the principal diagonal, and we have 1 and 2 in principal diagonal element, and these are the off diagonal elements. Okay, so if all the off diagonal elements are, in other words we can say, if all the off diagonal elements are 0 except the principal diagonal, or in other words we can say that if all the elements except the principal diagonal are 0 is called a diagonal matrix. So this is a 2 by 2 matrix. If we take a 3 by 3 matrix, that means 1 0 0 0 2 0 0 0 3. So this is a kind of 3 by 3 matrix, and here you all can see that these are the diagonal elements 1 2 3, and the off diagonal elements are 0. So this is called a diagonal matrix. Okay, and the diagonal matrix is also a square matrix. Then come to another type of matrix called upper triangular matrix and lower triangular matrix. So what is an upper triangular matrix? If all the elements below the principal diagonal are 0, if all the elements below the principal diagonal are 0, then it is called an upper triangular matrix. So here you all can see that A is a matrix having the elements 1 2 3 0 4 5 0 0 6. Okay, and this is a 3 by 3 matrix because we have row that is equals to 3 and column that is equals to 3. So here you all can see that this is the principal diagonal. Okay, this is the principal diagonal elements, that is 1 4 6, and this is the lower part of diagonal elements, or you can say this is the lower of diagonal element, and these are the upper diagonal element. Okay, of diagonal element. So here you all can see we have the lower of diagonal elements are 0. Okay, so we have lower of diagonal elements are 0, and this type of matrix is called upper triangular matrix, and this is also a kind of square matrix. Okay, and lower triangular matrix, it is the opposite of upper triangular matrix. That means if all the elements above the principal diagonal are 0, then we can call it as a lower triangular matrix. That means this is a 3 by 3 matrix, and this is the principal diagonal element. These are the principal diagonal elements, that is 1 3 6, and this is the upper part of the principal diagonal. So the upper part or the upper of principal diagonal elements are 0. So this is called a lower triangular matrix, and this type of matrix is also included under square matrix. Okay, so next type of matrix is called a symmetric matrix. So what is a symmetric matrix? If the transpose of a matrix is equals to the original matrix, that means if we transpose a matrix and after the transpose we are getting the same matrix, then we can call it as a symmetric matrix. For example, we have a matrix that is 1 2 2 1. So how we can do the transpose? So if we change the rows into columns and columns into rows, and this is called transpose. Okay, so these are the rows. Okay, 1 2 and 2 1. So this row we can write in column, that is 1 2, and this row, that is 2 1, we can write it in column. So this is the transpose, and after making the transpose of a matrix we are getting the same matrix 1 2 2 1 1 2 2 1. That means A equals to A transpose. So when in case of a matrix we are getting the transpose of a matrix is equals to the original matrix, then we can call it as a symmetric matrix. Then come to skew symmetric matrix. So if the transpose of a matrix is equals to negative of the original matrix, that means when we are transposing a matrix and we are getting the negative of that matrix or negative of original matrix, then we can call it as a skew symmetric matrix. That means we have A here, that is 0 minus 2 2 0. Okay, so if we transpose the matrix to A transpose, that means we have to change the rows into columns and columns to rows. So here we have the rows that is 0 and -2, so we can write it in column that is 0 -2, and here row is 2 0, so we'll write in column that is 2 0. So this is the matrix, transpose matrix we got, and we can write it as like minus 0 -2, or you can say if we take common minus, so we can write minus 0 -2 2 0. So this is the A matrix, so minus A, that means we got A transpose equals to minus A. Okay, so this type of matrix is called a skew symmetric matrix. And the last matrix, the type of matrix, is singleton matrix. Okay, so if we have a matrix having only one element or one entries in a matrix, we can call it as a singleton matrix. So here you all can see A equals to 2, so we have only one element, that means one row and one column. So this type of matrix is called singleton matrix. I hope you all understood the concept or types of matrix. So let's come to the question. Okay, so we have a matrix with dimension, that means order of m by n. So I have already told you that order of a matrix can be written as m by n. So the first number in the order is called row, and the second number in the order is called the column. So we have m rows equals to m, and column equals to 1. So I have already told you that if there is only one column in a matrix, okay, so here you all can see, if a matrix consisting of only one column, okay, and any number of rows, okay, the number of rows, you can take any number, but we have only one column, then that type of matrix is called a column vector. Okay, so in a matrix where we have only one column and any number of row, we can call that is that as a column vector. So here the option B is the answer. So answer is column vector. Answer is B, that is column vector, because we have only one column and m number of rows. So thank you everyone, hope you enjoy this series. Thank you.